Assalamualaikum my dear student, I hope you are fine today. Now we have to start the lecture on the mathematics for the daily basis. So we have to start chapter number 3, which is the name of the chapter number 3, the integration or antiderivative. It is very difficult the student to learn about this chapter to very hard. Now we have to start the first exercise, which is 3.1, and the question number 1. The statement of the question number 1, find dy and the del y of the following function. In each case y is equal to x square negative 1, or where x is changed from 3 to 3.02. Okay, here the question number 1 has the three parts. The part first to the part 3, which have the shape. So we can start. Here we can find the two parts. First of all, we take the statement of the question, x square negative 1. So we operate the day. Just we operate the day in this question. Day, where d is the derivative. D is the derivative. So we use the formula as x square. So we use the power formula in the derivative. So you know that the power we can write as the first, and we can decrease from 1, and further we have dx. Where 1 is the constant, so the derivative of the constant is 0. Okay, so we have 2x plus dx. You know that this value is x, and x is changed from 3 to 3 point this. So this value is dx. Okay, this value is here x is 3 and dx is equal to this. So we can put these values and get answer. 3, 0.02, 6, 0.02. Now after multiplication we have this. Okay, so this value 0.12 is called as the dy value. So we can find out the del y. We write it again. X square negative 1 we operate. You know that we find del y. So we can change from y to del y. Square x square plus del x square plus 2x del x negative 1. So we take the y on the right hand side and put the values from the above equation. Negative 1 x square negative 1. So negative sign will multiply both the values. The sign will be changed. X square cancel, and negative 1 x square 2x del x. You know that x is equal to 3, and this is changed at del x. We know that dx is equal to del x. So del x takes the value 0.02. Putting these values in 1. Square 2x3 0.02. After simplification we have this 6 0.02. One two, okay. 1204. So del y have the solution 0.1204. In this question we find two parts, dy and del y, by using the derivative of the function. So you learn it. If you have any feeling in this question, you contact me in my inbox. Please subscribe my channel and a new video coming to see that. So for the mathematics, especially today, we have to start the mathematics for the FSC, and now we have to start the exercise 3.1, and now we have to start question number 2. Question number 2 have contained the 3 parts. Question part first to part 4. Use the differential to find the value of dy over dx and dx over dy. We have only used the differential, okay, not d over dx. Differential means j. Just we can write as d the differential. D over dx means differential with respect to x. Okay, so we operate as d on both sides. We operate as d on both sides. So we can apply d on all values which is right in the bracket. You know that the derivative of the constant values will be 0. So here two functions we can use as the product rule. So we write as the first function, take the derivative on second function, and now we write as the second function and take the derivative on the first function. Okay, so dx and dx have the two values, so dx will be common on both sides. After taking common, we can write as, so dy over dx. We have y plus 1 into dx on the right hand side. The negative sign will be change. The sign will be changed. So we can find as d over dx. So we divide dx on both sides, and also we divide x on both sides. Dx will be cancelled, x will be cancelled. D over dx is equal to negative y plus 1 over x. So we find the first value dy over dx. Similarly, we can find the second value dx over dy. We take again the given function, and we have to find dx over dy in this part. Okay. Similarly, we can apply d on the both sides. Similarly, we can apply dx on the both sides and d operate in the bracket function. You know that the value of the constant, the derivative of the constant must be equal to 0. Here the function are 2, we use the product rule. So we apply the product rule. The first function of the given question we can write it and take the derivative or differential, or apply on the differential on the second function, and so we can write as the second and apply on the first function. These are the same as dx, mean differential of the x. So dy dx will be common in these values. Here we can find a dx over dy. We have write dx here and dy over dy on the right hand side. Dy on the right hand side. We can apply y plus 1 divided on both sides and dy divided on both sides, because we have dx over dy. So this form dx over dy complete here, we cancel each other and these cancel each other. So dx over dy is equal to negative x y plus 1. This will be the answer of the given question. Yes, student, you learn in this question number 2, which contain the part first of 4, use differential to find dy over dx and dx over dy. We just only use apply d. Where d the differential. You know that d the differential and d over dx differentiation, differential with respect to x. So we operate the d on both sides and we take d apply on xy. We have this result and this. So after simplification we get the final result. Similarly, you can find dy over dx over dy. Same process completely and get the final result. I hope you understand this question. If you are any failing in this question, please contact in my inbox and I can help you. Wait for my next lecture. Assalamu alaikum, my dear students. I hope you are fine today. Now we have to start the lecture on the daily basis for the mathematics, especially for the FSC, and we have to start the chapter number 3. We have to start at exercise 3.1 and the question number 3. The question number 3 has to contain the part from 1 to 4. Use differential to find the approximate value of this. So we use the differential to find the value of this. First of all, suppose x is equal to 16 and dx is equal to 1. The value of x is equal to 16. Here the values of the under root 1 over 4. So we can write as 2 raised to power. So we write as this value, not other values. And the remaining values contain 1 which has the dx. Okay. So y is equal to square root. After substitution we have this result and we can find as the approximate value, which is approximate value. Okay, this formula for find the approximate value, we have find first this and second this. 16 we can write as 2 raised to power 4 and we can write again 1 over 4 which is this. This implies that y is equal to 2 and we can write x 1 over 4. We can apply as d on both sides. 1 over 4 we use the power formula of the derivative and further we have dx 1 over 4. We put the value of x where x is 16. X is 16 negative 3 over 4. Okay. We can simplify this negative 3 over 4 and put in the value of dx into 1. 1 over 4, 2 raised to power 4, 3 over 4, 4 will be cancelled. So dy 1 over 4, 2 raised to power negative 3, we can write as the negative sign of the power will be cancelled, so we can take in the denominator. So sign will be positive. Okay, we can simplification 8, 1 over 32. After this we have 1 over 32, so we can write as the 32 0.0313. 0.0313. This is the value of the dy and this value is 2. So we can find as approximation value this. So we can write it and putting these values and get result. Okay, 2 plus 0.0313. Okay, 2.0313. This is the approximate value of the given function. This is the approximate values of the given function. We can write as 417 is 2.0313. Approximate value. I hope you learned this lecture today. This is not difficult, but it is important for the examination point of view in the exam start 2022. So you take practice this. If you are any failing in this question, you contact in my inbox. I can help you. Wait for me. Assalamu alaikum, my dear student. I hope you are fine today. Now we have to start the lecture on the daily basis for the mathematics, especially for the second year. And now we have to start the chapter number 3, which is the name of the chapter number 3, the integration or antiderivative. We have to start exercise 3.1 and we have to start question number 3. Use the differential and the approximate value of the cos 29. Okay, we have to approximate value. You know that the formula for the approximate value is y plus dy. So we can suppose or let y is equal to cos x, where x is, this is the value of the 29, the cos x, the function of the trigonometry contain complete values 30 degree, and remaining value is negative 1 degree. Okay, so first of all we find the value of y 30. Cos 30, the value contained of the cos 30 is equal to cos 30 is equal to 0.866, which is the value of this. We can find first value, so we can find the second value. Cos x, we can operate as d on both sides. The derivative of the cos x sin x, take the derivative of px. Okay, so we can change as degree into the radian. We know that 180 degree is equal to pi radian. 1 degree is equal to pi over 180 radian. We can take as this radian. We have final result of the 1 degree is equal to 1 degree is equal to 0.0173. 0.017. So value of we can write as dy negative x dx and negative the value of x is 30 and the dx contains negative 1. Dx contains negative 1 degree or 1 degree is 0.0173. We multiply as 0.0173. The value of sin 30, 1 over 2, negative sign will be cancelled. 7, 3. We have divided the value of 1 over 2 and we have so dy we can write as the final result dy the value of y is equal to the value of the y is equal to 0.0866. 173 over 4. Okay, we can divide as 0, 0, 8, 6. So 6, 4. We can write as addition 780. This is the approximate value of the given function. This is the approximate value of the given function. Okay, 8748. You know that this is the use the differential to find the approximate value of the quantity, which is not a difficult question. So we can learn and you learn it for the examination point of view. Please wait for next lecture. We can find the area approximate increase. We can find as approximate increase in area. In a circular describing named. Okay, if its diameter and its diameter is increased from this to this. Okay, you know circular discriminant, which is called as the center, where we denote the O is at the center. This is R, which is called as the radius, and this or diameter, where D is the diameter, the total length of the two radius, which is the name D is equal to 2R, which is the formula of the diameter and the R. Okay, so we have to find the area of the discriminant. Area of the discriminant. pi r square, which is the area of the circular discriminant pi r square. So where r is the radius, and the given in the statement the diameter is increased from this to this. The diameter is given but not radius is given. First of all we find the radius. So diameter change centimeter, and this is dr. This is dr. First of all we can change as 42 2r. We divide the 2 on both sides. This implies that r is equal to radius has the 22 centimeter. Okay. We have approximate increase, which define only d, differential dA by the constant. So we apply on this for 2r dr. We use the power rule. We can rearrange 2 pi r dr. Okay. So we can put the value of pi. We know that pi is equal to this, r is equal to 22 and dr is equal to 0.0. So we can change d is equal to 44.244, change 0.4. Take it 0.4. So we can put in these values in above equation and we get we put the value of pi and r 22 and dr 0.2. So we have after multiplication, the multiplication is and we have final result 27.6461 cubic unit. 6461. Here the question number 5, I again repeat the question number 5. Find the approximate increase in the area of the circular discriminant where its diameter is increased from 45 centimeter to 45.4 centimeter. We know that the area pi r square of the circular discriminant we define as the chain, which is the approximate increase in this. We have put in these values, we apply the day on differential quotient and put in these values, we get the final result. So we take the next question. Find the approximate increase in the volume of a cube. First of all, we define as a volume. First of all, we define as the volume. So x, y, here x, y, z both are equal. X is equal to y and y equal to z and z is equal to x. First of all, we define as the volume x, y, z. So using this value x, we define as dv. We find as dv where each length between x is equal to 5 and dx is equal to 0.02. We operate as d on both sides. We apply the power formula and further derivative, putting the values. The value of x is equal to 5, 0.02, 25, 75 is equal to 1.5 cubic unit. which is statement of the question number 4. Find the approximate increase in the volume of a cube if each length of each edge is changed from 5 to 5.02. So, first of all, we draw the cubic center. Which edge is x and denoted y, and the third denoted z. V is equal to x as well. We know that the value of x, y, and z are the same, so we can change into x, which are the multiplication, and so we have taken the x value 3 and we define the differential. We apply on both sides, then putting all these values and we get the final. I hope you understand this lecture, which is very important for the point of view of the examination. You prepare it for the examination 2022. Wait for my next lecture. So, thank you.